Okay. So already we have discussed up to session 8. So today's session is a 9th session, and the topic covered in this session is steam calorimeters. So till now we have studied the properties of steam, then how the steam phase change takes place, and how the formation of steam takes place. That's the conditions of steam. So there are different types of steams like wet steam, dry steam, and superheated steam. Later on, we have studied the vapor power cycles. So mainly two cycles. One is of Carnot cycle, and one more is the Rankine cycle, right? So up to this we have studied, and also we have solved some problems on the properties of steam, right? And today's session we'll see what is the steam calorimeters. The steam calorimeters, mainly these are the instruments. So used to measure the quantity of quality of the steam. The quality of steam means to find out the dryness fraction of the steam. ಸೊ ಸ್ಟೀಮ್ ಡ್ರೈನೆಸ್ ಫ್ರಾಕ್ಷನ್ ಅನ್ನು ಎಷ್ಟು ಡ್ರೈ ಇದೆ ಸ್ಟೀಮು, ವೆಟ್ ಸ್ಟೀಮ್ ಇದೆಯೋ ಅಥವಾ ಡ್ರೈ ಸ್ಟೀಮ್ ಇದೆಯೋ ಅದನ್ನು ನೀವು ಕಂಡುಹಿಡಬೇಕಾಗಿತ್ತಪ್ಪ ಅಂದ್ರೆ, ಸೊ ಯು ಆರ್ ಯೂಸಿಂಗ್ ದಿ ಕ್ಯಾಲೋರಿಮೀಟರ್ಸ್, ದಟ್ ಟು ಸ್ಟೀಮ್ ಕ್ಯಾಲೋರಿಮೀಟರ್ಸ್, ರೈಟ್? These steam calorimeters are used to measure the quality of a steam. Quality of a steam means the dryness fraction. You need to find out the dryness fraction by using these instruments. This is the measuring instruments. So that is called as calorimeters. Before going to study this calorimeters, so in this session, I am going to cover first the Rankine cycle with incomplete evaporation. So till now we have studied what is Rankine cycle and how the Rankine cycle works. So that we have studied in previous session, and these two are the special conditions. So these two conditions we will see it in today's class. So what is these two conditions? So first is Rankine cycle with incomplete evaporation, then Rankine cycle with superheated steam. Then later on we will see types of steam calorimeters, then barrel calorimeter, then separating calorimeter. So these are the contents I'm going to cover in this session. So the next one is Rankine cycle with incomplete evaporation. This is incomplete evaporation. So, so I have shown again the two graphs here. One is of a PV and one more is of TS again, same here. One is pressure volume graph and one is temperature entropy graph. So, right? So I have shown with the dotted lines. Dotted line that is original Rankine cycle. The original Rankine cycle was, it comes up to the 2, up to 2 point, then it comes to 3 dash, then it ends with 4. So
ಈಗ ಅಲ್ಲಿ ಮಾತಿತ್ಲೆ ಕ್ಲಾಸ್
ಯಾರು ಅವರು ಮಾತಾಡೋರು ಮ್ಯೂಟ್ ಮಾಡಪ್ಪ. So now in the Rankine cycle it goes up to 2 dash. 2 dash ತನ ಬರ್ತಿತ್ತು, ಆಮೇಲೆ 3 dash ವರೆಗೂ ಬರ್ತಿತ್ತು. ದಿಸ್ ಇಸ್ ಅ ಒರಿಜಿನಲ್ Rankine cycle, ಇಲ್ಲಿ ತನ ಇತ್ತು. But always in this Rankine cycle, so when it comes to the point 2, so when it comes to the point 2, so it is a wet steam, right? It is wet steam. But original Rankine cycle ಅಲ್ಲಿ 2 dash ಗೆ ಬಂದಾಗ 2 dash is what? 2 dash is the dry saturated steam. Dry saturated steam ಇರ್ತಾ ಇತ್ತು 2 dash ಅಲ್ಲಿ original Rankine cycle. But in this Rankine cycle ಯಾವಾಗಲೂ up at the point 2 dash ಬಂದಾಗ ಅದು ಡ್ರೈ ಸ್ಯಾಚುರೇಟೆಡ್ ಸ್ಟೀಮ್ ಇರಬೇಕಂತಿಲ್ಲ. ಸೊ ಅದು ಇರಬಹುದು, ಇರ್ಲಿಕ್ಕಿಲ್ಲ. ಸಮ್ ಟೈಮ್ಸ್ ಏನಾಗಬಹುದು ವೆಟ್ ಸ್ಟೀಮ್ನು ಇರಬಹುದು. ಆ ರೀತಿ ವೆಟ್ ಸ್ಟೀಮ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? when it becomes wet steam. So when it becomes wet steam, only the heat absorbed during that cycle is different. ಯಾವಾಗ ಇದು ಇಲ್ಲಿ ರೀಚ್ ಆಗುತ್ತೋ 2 dash ಗೆ ರೀಚ್ ಆದಾಗ the heat absorbed is something different. When it ends at the point 2, the heat absorbed is something different. 2 ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬಂದಾಗ ಹೀಟ್ ಅಬ್ಸಾರ್ಬ್ ಮಾಡಿದ್ದು ಕಡಿಮೆ ಇರುತ್ತೆ, 2 dash ಗೆ ಬಂದಾಗ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಬಟ್ ಒರಿಜಿನಲ್ Rankine cycle 2 dash ಗೆ ಬರ್ತಾ ಇತ್ತು. ಬಟ್ ನಾವು ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದೀವಿ ಟಾಪಿಕ್ ಅಲ್ಲಿ, ಇನ್ಕಂಪ್ಲೀಟ್ ಎವಾಪರೇಷನ್. ಇಟ್ ಮೀನ್ಸ್ ಟೋಟಲಿ ಎವಾಪರೇಷನ್ ಆಗದೆ ಇದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಇಟ್ ಶುಡ್ ಕಮ್ ಅಪ್ ಟು 2. ಸೊ 2 ವರೆಗೂ ಬಂದಾಗ ಏನಾಗುತ್ತೆ? when it comes to 2, the heat absorbed during complete cycle, it is X2 HFG2 plus HF2 minus HF3. So this is the heat absorbed during complete cycle, right? Because at the point 2 it is wet steam. 2 dash iddaga it is completely dry steam it originally, but idikina munche barodrinda, so I am using the dryness fraction here, x2 HFG2 plus HF2 minus HF3. So right, HF3 now. So this is nothing but this is the enthalpy of wet steam, H2. HF2 is the enthalpy of this is enthalpy of water, or I can say this is the sensible heat, plus this is the dryness fraction with the wet steam, so it becomes H2 minus HF3. So this is now becomes the heat absorbed during the complete cycle. So this is the one. So this is the one case where Rankine cycle with incomplete evaporation. That is the one case. In that case you have to use this, right? When Rankine cycle with superheated steam, when it becomes superheated, ಇಲ್ಲಿ wet steam ಇತ್ತು, ಈಗ ಇದಕ್ಕಿಂತ ಮುಂದೆ ಹೋಯ್ತಂದ್ರೆ when it becomes up to the point 2 now, ಇಲ್ಲಿವರೆಗೂ ಬಂತಂದ್ರೆ, ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, H2 becomes H2 superheated ಆಗಿಬಿಡುತ್ತೆ. ಅವಾಗ ಏನು ಬರೀತೀರಿ, Hg2 means it is dry saturated steam. So heat supplied to become dry saturated steam, that is becomes Hg2 plus Cp T soup minus T2. So this is superheat. After dry saturated steam, this much amount of heat is required to take the point from 2 dash to 2. So that you have to add, then H2 becomes now superheated steam, right? So that is, these are the two conditions for the Rankine cycle. So now we'll see what are the steam calorimeters. So steam calorimeters are the devices used to determine the quality or dryness fraction of wet steam experimentally. So we need to find out X. X is dryness fraction. This X, how to find out X experimentally? So experimentally we can find out the dryness fraction of the steam by using steam calorimeters, right? Different types of steam calorimeters are, there are these many different types of calorimeters are there. One is bucket calorimeter. This is also called as barrel calorimeter. Second one is separating calorimeter. So this third one is throttling calorimeter. So combined separating and throttling calorimeter, then electrical calorimeter. There are 5 types of calorimeters are there. So out of 5 you have 4 for your syllabus, only 4. Bucket calorimeter, barrel calorimeter, or separating calorimeter, throttling calorimeter, combined separating and throttling calorimeter, right? Now we'll see one by one. Out of these 4, so one question is compulsory. One question will come in the exam compulsory for 10 marks. So right. So now we'll see first what is barrel calorimeter, or it is also called as bucket calorimeter. So this is the setup. So what I am showing, this is the setup of the barrel calorimeter or bucket calorimeter. Sometimes he may ask in the question paper, with neat sketch explain barrel calorimeter or the bucket calorimeter. Both are same, right? So in this case, barrel calorimeter, what happens? Known mass of steam sample. Known mass of steam sample. So this is where the steam is there. From this, you are supplying steam to the barrel. This is a calorimeter barrel. This is called as calorimeter barrel, right? So here in this calorimeter, this is called as a calorimeter. He has shown here calorimeter. This calorimeter. So this calorimeter we are putting water. The water means that is a known quantity of water. So ಇಲ್ಲಿ ಹಾಕಿರ್ತೀವಿ ನಾವು. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we are putting the pipe. Pipe is there. In this pipe there are some steam nozzles are there. Openings will be there on this pipe. When the steam is passed from this pipe with the help of control valve, you need to control it, because you should know the quantity of steam supplied to the barrel. ಎಷ್ಟು quantity of steam ಅನ್ನು ನೀವು ಸಪ್ಲೈ ಮಾಡ್ತೀರಿ ಮೇನ್ ಪೈಪಿನ ಅನ್ನೋದು ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು. So ಅದಕ್ಕೆ is fix the control valve. It should enter now here. So it enters the water. This is a steam, means it is a wet steam. Wet steam iddaga matra namage dryness fraction ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಬರುತ್ತೆ. So this is a wet steam. So if it is wet steam, it enters the barrel layer. Barrel means where the cold water is stored. Cold water is stored. That too a known quantity of cold water is stored here. When the wet steam comes here, when it mixes with the water, then wet steam becomes condensed. ಅದು ಕಂಡೆನ್ಸ್ ಆಗಿಬಿಡುತ್ತೆ. ಅವಾಗ ಕಂಡೆನ್ಸ್ ಆಗೋದಂದ್ರೆ ಏನು, steam becomes water. So that mixes with the water particles. ವಾಟರ್ ಜೊತೆ ಮಿಕ್ಸ್ ಆಗಿಬಿಡುತ್ತೆ ಅದು. ಸೊ ಅದು ಮಿಕ್ಸ್ ಆದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ ನಿಮ್ಗೆ, ಹಿಯರ್ ದ ಲೆಟೆಂಟ್ ಹೀಟ್ ಅಂಡ್ ಸೆನ್ಸಿಬಲ್ ಹೀಟ್ ಆಫ್ ದ ಸ್ಟೀಮ್ ಈಸ್ ಗಿವನ್ ಟು ವಾಟರ್ ಅಂಡ್ ಇಟ್ಸ್ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್. ಸೊ ಅದಕ್ಕೆ ಥರ್ಮೋಮೀಟರ್ ಇಡ್ತೀವಿ. ಮುಂಚೆ ಒಂದು ಟೆಂಪರೇಚರ್ ಬೇರೆ ಇರುತ್ತೆ, ಯಾವಾಗ ನೀವು ಆ ಸ್ಟೀಮ್ ಅನ್ನ ಪಾಸ್ ಮಾಡ್ತಿರೋ, when it mixes with the water, then the temperature increases, right? So because of that, he is saying steam and water mixes together, and so condensation of the steam takes place and mass of water in the calorimeter increases. Not only the temperature, and even the mass is also increased in the calorimeter. Mass kunu kuda ille enagutte increase agutte. So that he wanted to tell you. Then how to find out this? So to find out this, so these are the parameters you should know. P is the pressure of the steam. It is in bar. Ts is saturation temperature. HFG is latent heat of vaporization at pressure P, right? MC is mass of the calorimeter. Cc is specific heat of the calorimeter. Me is water equivalent of the calorimeter. Water equivalent of the calorimeter means it is MC into Cc. So Ms is mass of the steam condensed. Mw is mass of cold water in the calorimeter. T1 is initial temperature of water and calorimeter. T2 is the final temperature of water and calorimeter. Cw is specific heat of water. X is dryness fraction of the steam sample, right? Then later on, heat lost by the steam. How to write heat lost by the steam? Ms is mass of the steam. Since the steam mass is wet, we are supplying wet steam, so it is X into HFG. Then this is what? This is the specific heat of water. Then there is a temperature difference. Initial temperature ಬೇರೆ ಇರುತ್ತೆ, ಯಾವಾಗ steam ಅನ್ನು water ಜೊತೆ mix ಮಾಡ್ತಿರೋ, then there exists a temperature difference. So this is saturation temperature, then this is the final temperature. So if you make both the subtraction, multiply with the specific heat, so addition of these two will give you the heat lost by the steam. Then what is the heat gained by water and calorimeter? So how the heat lost by the steam means that should be gained by some other thing. So it is gained by water and calorimeter. So how to calculate that? This is MW CW plus MC CC into T2 minus T1. T2 minus T1 is multiplied for both. MW CW into T2 minus T1 will give you the heat gained by water. MC into CC into T2 minus T1 will give you the heat gained by the calorimeter, right? So this is equating equation 1 and 2. The earlier is equation 1. So earlier is equation 1, then this is the equation 2. This is equation 2, right? So these two, if you equate, why you are equating these two? Because of law of energy conservation. When the law of energy conservation exists, when the heat lost is equal to the heat gained. So that obeys the laws of energy conservation. So now this is equal to this. If you equate both, then what happens in that case? Then you will get X. X is the unknown here. This X is the unknown here. So if you keep it X on the left hand side, then if you bring all the terms to the right hand side, then this equation becomes this. So this is the formula to find out the dryness fraction of the steam by experimentally. So by experimentally you can calculate dryness fraction. So these all the values on the right hand sides are known values. So from this you can find out the dryness fraction. So with this there is a limitation is there for this, the barrel calorimeter or bucket calorimeter. What are those limitations? So this method of determining of dryness fraction is not accurate. This is not accurate. So that's the one limitation. So then second one is care should be taken to prevent escape of steam bubbles in water. So you have to take the care. ಅಂದ್ರೆ ಆ ಸ್ಟೀಮ್ ಏನು ವಾಟರ್ ಜೊತೆ ಮಿಕ್ಸ್ ಆಗುತ್ತೋ ಅವಾಗ ಅದು ಹೊರಗಡೆ ಹೋಗ್ಲಾರಂಗ ನೀವು ಏರ್ ಟೈಟ್ ಆಗಿ ಮುಚ್ಚಬೇಕನ್ನ. ಸೊ ದಟ್ ಈಸ್ ಒನ್ ಕೇರ್ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್, so that the steam bubble should not escape from the water. So ಏನ್ ಸಪ್ಲೈ ಮಾಡಿರ್ತಾರೋ ಎಲ್ಲಾನು ಅದು ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಳ್ಳೋಂಗ ಆಗ್ಬೇಕಂತ ಹೇಳ್ತಾನೆ ಅಷ್ಟೇ. So these two are the limitations. So when you go to the next one, so in the next one is again, so this is called as separating calorimeter. The name itself says separating. Separating means you need to separate it. The water and steam should be separated. Water ಮತ್ತು steam ಎರಡನ್ನು ನೀವು ಏನು ಮಾಡಬೇಕು ಇಲ್ಲಿ, you need to separate it. So because of that the name is separating, right? So this is the arrangement again. Again, the steam should come from the pipe here. This is a sampling pipe. Again, there is a control valve to control to the known quantity of the steam should enter here. This is called as the perforated cup. So this perforated cup, below that there is again, this is a barrel calorimeter. So this is all barrel calorimeter again, right? So this is a perforated cup with this external chamber. This is the external chamber and this is the internal chamber. Or we can say this is the outer chamber and this is inner chamber. So outer chamber is connected to the pressure gauge, and this, the water is collected from this cup. This is connected to the water gauge. So water gauge to measure the known quantity of water, how much water is collected, and measurement we are fixing the water gauge here. So then this is the steam outlet. So this is steam is collected here and it comes outside. ಸೊ ಯಾವಾಗ ಸ್ಟೀಮ್ ನೀವು ಈ ಪೈಪ್ ಇಂದ ಪಾಸ್ ಮಾಡಿ ಇಲ್ಲಿ ಕಳಿಸ್ತಿರೋ, ಈ ಪರ್ಫೋರೇಟೆಡ್ ಕಪ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತಂದ್ರೆ ವಾಟರ್ ಇರೋದು ಮಾತ್ರ ಸೋಸಿ ಕೆಳಗಡೆ ಬರುತ್ತೆ. ವಾಟರ್ ಮಾತ್ರ ಈ ಹೊರಗಡೆ, ಪರ್ಫೋರೇಟೆಡ್ ಅಂದ್ರೆ ಒಂಥರ ಮಣ್ಣಿನ ಗಡಿಗೆ ತರ ಇದ್ದಂಗ ಅದ್ರ ಕಡೆಯಿಂದ ಪಾಸ್ ಆಗಿ ಕೆಳಗಡೆ ಬರುತ್ತೆ. ಸೊ ದ ವಾಟರ್ ಈಸ್ ಸ್ಟೋರ್ಡ್ ಹಿಯರ್, ವಾಟರ್ ಸ್ಟೋರ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ. ಓನ್ಲಿ ದ ಪ್ಯೂರ್ ಸ್ಟೀಮ್ ಏನಿರ್ತಲ್ಲ, ಆ ಪ್ಯೂರ್ ಸ್ಟೀಮ್ ಓನ್ಲಿ ಇಟ್ ಎಸ್ಕೇಪ್ಸ್ ಹಿಯರ್. ಆ ಪ್ಯೂರ್ ಸ್ಟೀಮ್ ಮಾತ್ರ ಔಟರ್ ಚೇಂಬರ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ಕಮಿಂಗ್ ಔಟ್ ಫ್ರಮ್ ದ ಸ್ಟೀಮ್ ಔಟ್ಲೆಟ್, right? So our steam energy, that pressure is measured in the pressure gauge, right? This is the arrangement here, right? The wet steam enters at the top of the calorimeter through a control valve as shown in the figure. This is the control valve, right? It strikes the perforated cup. When it comes here, it strikes the perforated cup here. When it strikes the perforated cup and thereby undergoes the quick reversal in the motion. Quick reversal in the motion means ಇದು ಯಾವಾಗ ಈ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗುತ್ತಿರುತ್ತೋ, ಈ ಕಪ್ ಅಲ್ಲಿ ಬಂದ್ ಬಿದ್ದಾಗ ಇಮಿಡಿಯೇಟ್ಲಿ ಡೈರೆಕ್ಷನ್ ರಿವರ್ಸಸ್. ಯಾಕಂದ್ರೆ ಕಪ್ ಐತಿ, ಕಪ್ ಅಲ್ಲಿ ಬಂದ್ ಬಿದ್ಮ್ಯಾಗ ರಿವರ್ಸ್ ಆಗ್ಬಿಡ್ತಾರೆ ಡೈರೆಕ್ಷನ್. ಇಲ್ಲಿ ವಾಟರ್ ಪಾರ್ಟಿಕಲ್ ಇತ್ತಂದ್ರೆ ಇದ್ರ ಜೊತೆ ಪಾಸ್ ಆಗಿ ಸೋಸಿ ಇಲ್ಲಿ ಕೆಳಗೆ ಬರುತ್ತೆ ವಾಟರ್ದು. ಸ್ಟೀಮ್ ಅಷ್ಟೇ ಈ ಔಟರ್ ಚೇಂಬರ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ರೈಟ್? ದ ವಾಟರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಡ್ಯೂ ಟು ದೇರ್ ಗ್ರೇಟರ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಟೆಂಡ್ ಟು ಮೂವ್ ಆನ್. ವಾಟರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇನರ್ಷಿಯಾ ಅದ್ರದ್ದು ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಕೆಳಗಡೆ ಬಂದು ಇಲ್ಲಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ, right? And consequently get separated from the mixture. It consequently gets separated from the mixture, right? The separated water collects at the bottom of the inner chamber and its amount may be determined by the graduated water scale. How much water is collected here, so that is to be measured with the help of water gauge, right? Then the amount of dry steam leaving the outer chamber of the calorimeter may be measured by condensing it in a weighted quantity. So ಯಾವಾಗ ಸ್ಟೀಮ್ ಹೊರಗಡೆ ಹೋಗುತ್ತೋ, ಆ ಹೊರಗಡೆ ಹೋಗೋದನ್ನ ಇಲ್ಲಿ ಇಲ್ಲಿ ತಗೋತೀರ, ಔಟ್ಲೆಟ್ ಅಲ್ಲಿ ತಗೋತಿರಲ್ಲ, ಇನ್ ಔಟ್ಲೆಟ್ ಯು ಕ್ಯಾನ್ ಕಂಡೆನ್ಸ್ ಇಟ್. You can condense it and then you can measure how much the steam is condensed, or you can directly measure from the pressure gauge. So these two quantities you can measure. So then later on, with the help of this formula, that is X is equal to mass of dry steam to the mass of the wet steam. So with this formula, you can find out what is the dryness fraction, mass of dry steam, mass of the wet steam. So that is mf by mg plus mf. This is the formula used to measure the the dryness fraction, right? This is the 2 calorimeters. So for this I have referred this Kurmi book, right? RS Kurmi and JK Gupta book. Okay, thank you.